Hello, hello. Hi, folks. Welcome to the final part of the Docker series. And today we are going to deploy what we have built yesterday. So the images that we built for our Monstack application, we are going to actually deploy that so that our end users can use that. So super excited to welcome everyone to the stream. Hello, hello. Hi, everyone. I will just wait for a bit more time so that other folks can join in, and then we will get started. You can tell me where you are joining from. Also, how was the Global Hack Week for you all? Please let me know in the comments. And also during the stream, if you have any questions, just feel free to hit that up on the chat, and I will be more than happy to answer your questions. All right, let me pull up my screen. I hope you can see that. So I guess we can begin now. Cool. So hi everyone, I'm Sagar and I am a coach here at Major League Hacking, and I work professionally as a DevOps engineer. So taking the product of our clients and making sure that it runs properly at a scale. So that is what I do on a daily basis. And I'm so super excited to start my master's degree at the Technical University of Munich this October. So super excited for that as well. You can connect with me on my socials. I am mostly active on Twitter, LinkedIn, and Instagram. You can find my handles in the slide. Hi, everyone. Hey there. We have Hey Skitty. Welcome, everyone. Welcome back. Welcome back. So again, welcome to this place where I call it as a container land. It has a lot of things to do in not only for the developers, but for I guess everyone, because nowadays most of the applications that we use, most of them are using the Dockers and containers in order to manage that at scale, especially during production. So welcome to the container lot. Now, another important info that I want to share with you all is the session resources. So I've compiled all the session resources, not only for this part. So this is the final part of the series, but you can get the resources and also the recordings as well as everything that I did on this specific Notion page. So I've compiled all of them in this Notion page. So please make sure that you bookmark this page. I'm also going to put this on chat so that's it. It's easy for you all to follow along. Let me just quickly copy and paste this in chat, and I hope you can get that. All right, so I have also displayed it on the screen. We have Avinav. Hello, Avinav. Welcome back. All right, and also recommended follow-up is the previous deployment session which I did it in Azure. So this was another standalone session which I did before the Docker series, where we deployed the Monstack application in Microsoft Azure, but that was without using Docker and container. So all of that, we did not use that, but I would recommend you to see this session as well, because we're using the same code base for the Docker project as well. So it will help you to understand how the project is structured and what configuration you need to do in order to set the application up and running in your machine and also in the cloud. So that is going to provide you the context. So please watch that up as well. So just recapping everything that we did in part one and part two before I start the final part of the series. So first, in the part one, we learned about what Docker is, what containers are, and why do we need them. And also, we talked about the different Docker commands. We talked about Docker networking. We also talked about Docker volumes and how it helps us to receive persistent storage. And then we did a demo of everything that we discussed. And in part two, which was yesterday, we wrote a Docker file for our front end as well as the back end. The front end of our application was in React, so we containerize it. We talked about the different Docker file instructions and how to actually build it, provide different arguments and environment variables. We did all of that. And then we learned how to actually publish this or share this artifact or container image to everyone else using the Azure Container Registry, so which is a private registry service by Azure, Microsoft Azure Cloud. By the way, you could also do this with Docker Hub. We learned about how you can pull different images, use them in your application. We also learned about Docker Compose, which helps us to run multiple containers at once, so without the need of building and typing the Docker run instruction with all the arguments, which can be tedious at times. You could use the Docker Compose to quickly spin up and spin down your container. So that is what we did. And finally, we published the images for both our React as well as the Express application to the Azure Container Registry. So now our image is already up there in the cloud. So now the only thing that is remaining is to deploy them, right? And that's exactly what we are going to do in this part. So we'll learn how to deploy containers. And for that, there are actually a lot of services in different ways, which I'll just talk in a brief moment. But we are mostly going to be focused on the Azure Container App service, which is a great service which helps you to deploy containers, and it takes care of a lot of the management side of stuff. So you don't need to configure a lot, but still provides you some extensive configurable options. So if you want to do certain things differently, then it also provides you that customization option. So that is why we're going to use this. And since our image is already there in container registry, it's going to be pretty easy for us to just quickly link that up with container app. And we'll see all of that. And finally, we will also set up a CI/CD pipeline. So that will automate the entire process. So whenever you have any code changes or feature upgrade in your application code and you push that to GitHub, a new image of your application will be built, and that image will be first pushed to the Azure Container Registry, and then the Azure Container Apps will get that image and finally run that container. So everything will be automated with the help of a CI/CD pipeline that we will set up using GitHub Actions. All right, so let's get started. This was the application that we used, just the basic structure which I already showed. So it was a React.js application which our client or the users will use. And then for the backend, we had the Express.js framework, which utilizes Node.js. So that was our server. And for the database, we used the MongoDB database. So we set up a database in cloud using MongoDB Atlas, and then we link that up with our backend. And that is how the connectivity works. So front end, user access the front end, and the front end communicates with the Express API, and the Express API indeed calls the MongoDB to fetch the records. And just a quick recap. So containers, like we talked in part 1 and part 2. So it's basically a bundle of everything that our application needs to run. So it's the bundle of the code that our application needs, also the runtime or the environment where the application needs to run. So this could be Node.js if you're using a JS stack. It could be things like Fast API, the Python environment. If you're using Java, then this could be the Java runtime environment. Also the dependencies that an application needs. These are the NPM packages or the PyP package if you're using Python, or Maven or Gradle package if you're using Java, and similarly it goes on. And also some of the operating system packages. So if your application needs some of the OS functionalities, then you also need those packages. So you bundle everything this, and that is what we call as a container image. And once you have the image, you can start it, and that running instance of a container image is called a container. So you have the image, and once you run it, it is called as container. So that and if you want to write your own image, so let's say you have your own application that you want to containerize, then you normally write it in a Docker file. So you create a Docker file for your project for each of the container that you want. So for front end, it's going to be one Docker file. For back end, it's going to be a different one. And likewise for the services you have. And you write the instructions in Docker file, which we covered in the second part. And then the Docker builder, which comes with Docker Engine, builds it. It builds in terms of different layers, so that whenever you have a new revision of your application, it can reutilize some of the existing layer, and that will speed up the build process. If you are not getting what I'm saying right now, please don't worry, because all the recordings for part 1 and part 2 are already there in the YouTube and also in the Notion page, which I have provided to you all, so you can rewatch that and do it yourself to get more familiar with this. All right, so we did all of that. We also saw how we can write a compose file and use Docker Compose to run our application. So this was the example that we used. And then we saw how we can actually share our image with other users, and also if we want to deploy it to the cloud, we need to publish it somewhere. So we saw the different options, like the default, which was Docker Hub, but it does not provide unlimited private repo. We need to pay for that. Docker Hub only provides us with one private repo. So that is why we used Azure, because we get $100 free student credit with that, and we can use that to publish multiple images. And we also have the AWS Container Registry, Elastic Container Registry, we call it ECR. And then the Azure Container Registry, similarly, there is also the Google Container Registry as well. So we are going to use the Azure one for our demo. We saw how we can log into the different registries, and then we need to retag it in a specific way. which comprise of the URL of the registry, and then we need to retag it in that format, and then we can push it. So that is what we did. And just briefly talking about the GitHub Actions, which I covered in the Azure session that I did, deploying web apps with Microsoft Azure. So even link for that is also provided in the Notion page, so you can watch the recording. So there we covered about GitHub Actions, which is basically used to automate the deployment process. So whatever we did manually in our terminal, so we did Docker build, and then we before Docker we used the npm packages, we installed them, and then we run the npm package. But with Docker we don't need to do all of that. We just need to build the image and then run the image, right? So all of this process will be automated, even pushing the image to the container registry, and then finally taking that image from registry and using that image to build a container apps in Azure. So all of that will be automated with the help of GitHub Actions. So whenever we push any changes to certain specific branch, an event will be triggered. So this is going to be, let's say, a push to a main branch, or any other branch that you want, or a pull request, and that will execute a series of steps. And that steps will tell GitHub how to actually go ahead and build the Docker image, and then push to ACR, and then run it in Azure. So that's about GitHub Actions. Now let us try to actually deploy this container. So for that, today we are going to use the Azure Container App Service. By the way, there are other options with other cloud service providers, such as the Amazon Elastic Container Service with AWS. We could also use Kubernetes to deploy our application, but that's a bit overhead for our simple application. We don't need Kubernetes. But if you're working in production environment, and later in a career if you're working for companies which have a lot of different microservices, then Kubernetes is another tool that comes out with a lot of different options for you to manage and scale your containers. So that's another option how we can deploy. We can also use other serverless settings, or the features of other cloud service providers, such as Google. We have the Cloud Run service. But since we are already using Azure, as it provides the free student credit, and then we already have our image in Azure, so we're going to use this. And Azure Container Apps is used for multiple kind of purpose. So you can see that it provides the public API endpoint. So that means that we can deploy our application or containers as an API endpoint, which is exactly the thing that we are going to do today. So our front end and back end will be exposed as the public API, and that is how our front end, we will be able to access the front end, and also the front end will be able to access the back end, because all of the request and processing is going to be based on the HTTP routes. So that is how we can do it. Also comes with a lot of other flexibilities, such as we can split the traffic. We can also do different revisions. So whenever there is a change in your Docker image and you update the Docker image, you can deploy a new version without reducing all the traffic. So let's say 80% of your traffic is going to be to the old image, and then the 20% with the new image. So that way you can do the progressive deployment as well, so that none of the users get affected. Right. Just a second. Okay, yeah, good. All right. Then we can also do background processing with it. It also provides some of the background jobs. So let's say you just want to execute certain things in the background, and you don't want it to be exposed to the outer world. You can totally do that with Azure Container Apps. It also provides event-driven processing. So let's say if someone places an order in an e-commerce application, then that could be an event, and you could trigger a lot of containers based on that. So a series of container which will be executing your order process. So that will be run, and once the processing is complete, the containers can shut down themselves. So that will save you a lot of cost as well. And we can also do microservices. So if you have a lot of microservices, then all of them can be deployed. And it also provides the service-to-service communication. So if you want a microservice A to communicate with microservice B, then that is also possible with Azure Container App. So yeah, a lot of flexibility that comes with Azure Container App, and that's why we're going to use that. And this is going to be exactly the flow that we will be using today. So we are going to put our code in a GitHub repository, which is already out there. If you have followed part 1 and part 2, you already know this. If you have not, then there is a link to a GitHub in the documentation that I provided, which you can see on the screen right now. And then this will, whenever there is a change, a GitHub action will run, and that GitHub action will actually build the container image and then push it to the Azure Container Registry. And then every time there is a change, there will be a new revision deployment which will be used by the Azure Container Apps. So that is what we are going to do. And now let us go straight into the demo and see everything in action. But before that, I do see one question. Let me quickly answer that. Okay, this is a bit of interesting question. How hard the job as a DevOps engineer actually is? Because I see there's just so many things and tools to learn about DevOps. Do you know how to use all of them? That's a really good question as well, and it is not only applies to DevOps field. It is also, I believe, similar to in the development field or any other field, especially in the field of IT, because we do have a lot of technologies and tools that is coming up every now and then, right? And even in DevOps, it might be overwhelming, especially for beginners, because you need to learn a lot of different things, and there are different cloud service provider, and each cloud service provider has their own set of services, and there are also open source tools. Especially if you look into the cloud native computing foundation services, there are like hundreds of other tools just to manage Kubernetes, and the ecosystem revolves around Kubernetes. So think of one product, which is Kubernetes, and there are hundreds of products revolving around that. And that is just one product, but there are similar lot of other tools. But I would say that it all depends on how you can actually prioritize or focus on some specific domain. So we cannot be a master of everything. So I would just recommend you to start with basic stuffs, like get your foundation right, which you are actually doing by following this series. So Docker is the basic foundation, which will lay up, and it will help you in every other way. And also I would say learning Linux is a really good skill to have. The playing with terminal and as much as avoiding the graphical user interface, that's going to help you as well. So start with Linux, and then start with Docker, start with very simple application, don't go too complex, and then one after the another increase the complexity. Do not go too bored at once. You don't need to be master of everything. You can specialize in certain things, and that will work. We cannot, even I do not know all of the services. That's, I believe, no one knows that. It's just about specializing, and as the work comes up, you will learn new technologies. So you need to be a good learner and just keep up with the technology, lay your foundation right. So things like Linux, networking, and then the Docker, containerization, the CI/CD pipelines, all those things. Those are the basics that you need to master, and then you can catch up. All right. So let's go. I hope that answers your question. So let's go ahead and see all of this in live demo. All right. So let me pull up the my code. So just before I show you the Azure portal, just wanted to quickly recap everything that we did. Just a second. All right. So if you have not already, please go ahead and check into the event first, because that will give you some point, and you might be eligible for some Global Hack Week swags, the stickers and the postcards. Please go ahead and check into the event. The link to check in is in the chat. So I'll put that in the chat as well. Please go ahead and check in if you already have not. And then also please go through the documentation that I provided, or the guide, because it contains a lot of information about all the parts. So you can click on the prerequisites to check what you need to have installed on your machine. So things like Docker and the Microsoft Azure account, the MongoDB account, and all those things. And then we have in part one, you have all the codes that we used in part one. And then similarly for part two, and then the instructions that we will have in part three, right? So all of these are already up there in the Notion page. So I would recommend you to follow this up. All right. That was about the container registry, right? So now let us go ahead, and you can also, by the way, look at the recording for part one and part two, which is provided in this page. So let me quickly go ahead and explain you the code that we have over here. So this is basically a Monstack application. You will find the link to the GitHub repo in the Notion page that I shared. So go ahead and clone that application. So inside the app directory, so we have the client, so which is the React application. And then you have a .env file, which provides the API URL. And this is the URI. If you are running this locally, since the backend, which is Express, runs on port 5050, so you need to provide that URL. If you're running the backend on a different port, then you can just change this value over here. So that is the in configuration that we need to do, and then the static or the React files are in the src folder. So that was about the client. For the server, we have a Node.js based Express framework. We have used that over here, and you can see that the code are inside the route folder. So these are the different API routes that our application has. It's basically list up the different employees that we have in our company. You can edit the record of the employee. You can add a new employee. You can delete them. Based a simple CRUD application, nothing fancy over here. And then you need to provide the MongoDB Atlas URI in the config.env file. So you need to provide the full URI, including the username and password. And we already learned how to set up this in our previous parts. So go ahead and check that out. So basically, we provide the URI. We create a MongoDB database in Atlas, and then we copy the URI and set up the in configuration over here. And we also provide the port. So by default, it runs on port 5050, but if you want to change the port where the backend is running, then you can change that over here. So that is what we did in the server part. And finally, we built our application using Docker files yesterday, right? So we both the client and the server has a Docker file, and this provides the instruction on how you can actually build the image for your application. So we did it for client as well as for the server as well. You can see that we have two different document files for client and then server. And then we also learned about Compose, which helps us to run both the front end and the client with the different configuration and the network options. We put them in the same network so that they can communicate. We also provided different build arguments. So build argument, we provided for the React app because it needs to have the API URL inside it. And we also provide a runtime argument with the help of env file for our backend. So that is what we did yesterday. And if you remember, we also pushed the image from our local machine to the cloud using Azure Container Registry. So if I do Docker images, oh, the Docker daemon is offline. That Docker has not started. So let me quickly start the Docker desktop, and that will start the engine for me. Yeah, so you can see that the engine is starting. And once it has started, we can use the Docker commands. All right, so now the engine has started, so I can go back to my terminal and I can do Docker images. And now you can see that we did have different images. So these were the local events, one for the React and one for the Node.js, but we retagged it to the format that was required by our Azure Container Registry. So we need to prefix our image name with this container registry URI. So we need to provide this, and then we push this, right? So if I could pull my browser, you can see that if I go to Azure portal, and if I go to Microsoft Azure and then under container registry, you can see that I already have the GSWMon backend registry and as well as the GSWMon frontend registry. So each of them has the image for our frontend and backend respectively. So if I go to backend and under repositories, you can see that I have the Node.js API backend, right? So this is actually the image that we have. And then we pushed one image yesterday with the latest tag. So that is the one. If you are going to give it a specific tag, then you can just append the image name with colon and then the specific version. Let's say 1.0, 1.1, 1.2, then it will show up over here. So that is what we did. And for similarly for front end, we also see that under repositories, we have the React application image over here, and you can see that the image is right here, right? So you can get details about the image and then the different digest has and everything. So when it was created, you can see the timeline and everything. And if you want to pull this image, then you can use this command to get this in your own local machine or to share it with anyone else. But they need to have the appropriate permission to access these repositories. Otherwise, they would not be able to access. And for that, you can use the access control tab over here, and you can add other users by, if they are already in the Azure ecosystem, then you can simply add with their email. If they are in the same organization, that's going to make it more easier for you to grant access to this repository. So these are both the private registry. By the way, another important thing is that if you want to save cost, and also if the applications are related, then you can put all the images within the same registry itself. So just for the demonstration purpose and to show you that it is possible, I have put both the front end and the back end in different registry, but you could ideally put them within the same registry itself. So under registry, it's going to be the same registry, and under repositories you could put two different images, like we have one for backend, right? So under repositories we have two different images, but we can totally do that. That's totally fine as well. So that was about how we push the image. So let us go ahead and now create the Azure container environment, and then let us see how we can actually deploy our application. All right. If you have any questions, then please let me know in the chat, and I'll be more than happy to answer. All right. So you need to search for container apps, which I have already done. So go ahead and search for container apps. And once you are inside the container app, you need to click on create. So let us go ahead and create a new container app, right? Remember that we have already completed all the process up until pushing the image onto our container registry, right? So yeah, and also let me quickly show you the uh, GitHub repo, right? So this is actually the repo where our code is, right? And for the demo specifically, I'm not using the main branch because that has all the final code that our application looks like, how our application look like with all the CI/CD pipelines and everything configured. So since I wanted to show you step by step, so we are using the GSW Azure branch. By the way, you could use any branch that you want. But for the demonstration, we are using the GSW Azure branch. And right now we have two workflow. So ignore the clean backend workflow. So that is the one that I tested before. But we previously had two workflows, Azure Static and Azure Web App. So these workflow are not the part of the Docker series. Please do not be confused with that. These are the part of the standalone Azure series, Azure session that I did previously. So you don't need any of the two workflow for this specific session or for the Docker session to work. This was for the session where we did not use Docker, but still we deployed it to Azure. So these are for that session and not this one. And you can ignore any of these. For now, remember that you do not have any work. Imagine that you do not have any workflow file in your repo. So yeah, so we're going to start from the basic scratch. Just note that our code is inside CSW Azure, and right now you don't have any workflow file. All right. That is about it. So let me quickly go to Azure portal. So let us give it a name. So first you need to select a resource group. So since if you have already a previous one, then select that. Else you can create a new one. So I'm gonna put it in the GSW1 resource group. Otherwise, you can just give it a new name and create a new one. Resource group is nothing but basically the collection of all the different Azure services which are related to one project. So since I am going to create two container apps, one for the front end and one for the back end, and both of them are related to the same project. So I'm going to put them in the same resource group. And also there might be other services I use for my application, such as logging or the monitoring services that if I want, then I can also put that in the same resource group. So basically the collection of all the other services which are related, and that logically makes sense. You can put them in the same resource group. All right, so we're gonna give it a name. So that is gonna be GSW mon frontend, right? I think I'm not allowed to use dash, so GSW mon frontend. So that's gonna be the name of my container, right? And for the deployment source, so there are two different options. So one is to use the container image, right? So since we already have our image in Microsoft Azure itself, we can use that. So that is why we're going to choose this. But let's say if you did not have the image and if you don't even have a Docker file, then Azure will try to create its own Docker file by itself and try to deploy it from the source itself. So if you just have the source code, then it will try to create a Docker file and it will try to deploy it itself. But many times it might not work because your application needs some specific configuration which might not be compatible with the default way how Azure handle thing. So you need to have some additional configuration as well. So that is why I recommend choosing the container image, because you are in charge of that way you are in charge of how your image is actually built. So we are going to choose container image because we already actually push that image to Microsoft Azure. All right. And for our container apps to run, it needs the container app environment, right? So for me, it already shows one container environment. And by the way, for a reason, please select the one which is nearest to your location. That way, whenever you make request to your application, the latency is going to be reduced and you will get to access your application in a faster manner. Yeah, so always choose the one which is nearest to your location. That's the reason. And if you don't see any container environment app over here, which might be the case if you have not created one before, just click on create new. and it will take you to this specific page, and you just need to provide it a name, nothing else. You can do test environment or something like that, and then disable the zone redundancy, because this is not for production, this is not meant for production. If you enable this, then your container environment will be replicated in multiple availability zones, which we don't need right now. So for the sake of demonstration and to save you your Azure credits, please select disabled, and then you can create one. It might take some time for the environment to be created, but once the environment is created, you can come back to container apps. Just a second, I'm going to cancel this. Yeah, since I already have created the environment, you will be able to see that over here. And once you see the environment, then you can proceed. So I'm going to click on next. And for the container, so here are like different ways of configuring your container. Here you need to provide your container details. Like, so we need to provide the Docker image source, right? So since we are using Azure Container Registry, because our image is already up there, we can choose that. But you could also actually access the registry, other registry like Docker Hub or the Elastic Container Registry or anything like that. So if it's a public one, then that's going to be super easy, because the authentication process will be skipped. So you can easily access the image. But let's say if the image is not in Azure Container Registry, and if you're using, let's say, a private Docker Hub registry or the Amazon AWS Elastic Container Registry, then you need to provide it with the registry username and the password as well. So that's going to be some additional hassle that you need to do. So you need to make sure that Azure can access the other container registry that way. So you need to provide the username and registry, which you can get from the other private registry settings. But we are not going to do that. We are going to choose Azure Container Registry, right? And then we can select the registry now itself, like we already have our image in backend and front end. But I'm not going to do that right now, and I'm just going to use a quick starter image. So imagine a situation where you don't have your image ready yet, right? So, and you want the image to be built from the CI/CD pipeline itself. We don't normally do until and unless it's a development stage. Even in development, we don't do that, but we don't use the Docker commands manually to build our image and then push it to ACR manually. We don't do that. We set up all of that behind a CI/CD pipeline, so that the pipeline will do that for us automatically. So whenever there is a change in the code, and we push it to GitHub, then the pipeline will actually build the image and push it to the Azure Container Registry, and which will be used by the container app. So we don't do it manually. So that is why I'm going to use quick start image for now, and I'm going to set up a CI/CD pipeline which will actually build the image for me. So yeah, so that's going to be a different way, and actually the way I would recommend you to follow as well. So just for development, it's totally fine to push the image yourself and use that, but that's going to be a bit of hassle if you changed your code and now you want a new image, so you have to build it again, and then you have to again connect with Azure and then deploy it manually from the terminal, which is hassle. So we set up a CI/CD pipeline. So that is why I'm not going to select any image for now and just use a default image. So this is basically a placeholder image. It does displays a static page saying that the container is running. So this it's just a static image which is provided by the Azure team themselves. So you can see that it uses a very lightweight CPU and the memory of 0.5 GB per container instance. So that is important. And right now, the ingress is enabled. So ingress is nothing but a fancy word for saying all the incoming requests. So by default, this will be enabled. So if you disable the ingress, then your application will not be accessible to the internet, or no one else in the internet will be able to use it. Only your internal application and services which is already running inside the Azure will be able to use that. But if you, let's say, if it's a website, then you want it to be accessible to the internet and to the client, right? So in that case, you need to enable ingress. Otherwise, the external users will not be able to access the application. So we keep it as enabled, and that will be an HTTP endpoint, and it will by default listen on port 80, which is the default HTTP port, right? So if you want HTTPS, then that's going to be a bit different case. But for default, for our case, on port 80, it's totally fine. So this is actually the port where the application will be served. Your container will be running on a different port. Remember, that's a different port and this is a different port. So this is the port where the application will listen, right? So your once the container is started, the container itself, in our case, for example, the backend runs on port 5050, and the front end, since we build the React application and serve it using Nginx, right? So we serve the front end using Nginx, and even Nginx also use port 80, right? So that's the container port. Remember, it could be 5050 like for our backend, but this is the port where the application for ingress port is the port where the application will listen the traffic, and target port needs to match the container port. So if your container is running on 5050, you need to set up the target port as 5050. This is totally fine for our front end. So what was this one? So this was for our front end, right? So this was for the front end. For front end, the target port is totally fine because Nginx also uses port 80. So the listening port and the target port are same in this case. But for our backend, we need to change the target port. We need to make sure that the target port is 5050 and not 80, right? Because the traffic will be served on the Nginx in the ingress URL, but it will send the request to the container port. So that's the target port. You can find the information over here as well. We are going to skip the binding. We don't need that for now. You can give it any tag, or if you want some labels for your application, you can use that. And now let me go ahead and create this one. So my validation is passed. So I'm just going to create this one. All right. So in the meantime, I'm also going to create a second container app, and that's going to be for the backend, right? So, all right. So this is in progress. So in the meantime, let me go ahead and create a new one. And this time it's going to be for my backend. So I'm going to put it in the same resource group as earlier, GSWMon Azure, right? So this is going to be GSWMon backend, right? And again, the source will be image. Sorry for that. And then the reason is going to be India again. And then select the environment that you have. That's going to be totally fine. And for the container, again, I'm going to use the quick start image. I will set this up from the CI/CD pipeline so that my container app can use the CI/CD pipeline, and then pipeline will do everything like building and then pushing it to Azure Container Registry and then running that in the container app. So that will be taken care by CI/CD pipeline. So I'm not going to use anything for now. And for our backend, I told that for backend, we need to set up target port as 5050, right? Because if you remember, and if you go to the Docker file for our backend, I am quickly going to show that. You can see that it is exposed on port 5050. So that means that the container is actually listening on port 5050. But you can see that here we are setting target port as 80, right? So this is not good. But actually, this is not the target port for our backend container image. So you need to be careful with that. This was for the quick start image, right? So it was for the quick start image and not for the actual image. So we are going to change this port later on. Remember that we need to change this port. Otherwise, our application will not run on port 80. It will only use the quick start image. So that it was the port where the quick start image will listen. So that is why it's port 80. But we need to change this once we create this container app. So remember that for binding, I'm going to skip, and then I'm just going to create this as well. All right, so let me create this, and let us just wait for this to complete. In the meantime, like if you have any questions, I would be more than happy to answer that in the chats. All right. Okay, so this is running. Let us wait for just a second. All right, so let us actually go to the back of one and see how it looks, right? Okay, both of them is now completed. So let me actually go to backend first. So this is how the container app will look like for your backend. And you can see that we do get an application URL, right? So this, if you click on this right now, it will just load a static page. You can see that it's the hello world or the quick start image that we use. This is not our actual backend application, right? So it's not using the backend image right now because we will set that up from the CI/CD pipeline and not manually. Right, so you can see that it's using the port, the hello world quick start image, and by default, if you remember, then it was using port 80, right? So that is why it is able to. It is sorry, you don't need to type port 80 over here. It's able to access the application, right? So that was port 80, and even it's going to be the same for the front end as well. So let me go to the front end deployment. All right, front end deployment, and we do have a separate URL. So this is a different one, and this is a different one, right? So you can see that it does says that the application is running as well. So both the front end and the back end is running, and you can see that we have a different settings options available, and here is the area where we need to change certain things. So for front end, we are not going to change, because even for front end, you can see that if I show you my Docker file for the front end, let me quickly show you that the front end also listens on port 80, right? Because it is being served by Nginx. So first, This is multi-stage build, which we already covered yesterday. Please refer to the stream of yesterday to understand this. So we built our application and we only serve the dist folder using nginx. These are the static files. We are using nginx as a static web server, right? So since it's listening on port 80, it's totally fine that I leave the target port as 80. And you need to make sure that the ingress type is HTTP, because this is a web application which uses the HTTP protocol, and it should be able to accept the traffic from anywhere. We don't want to limit the request within the Microsoft Azure ecosystem itself. So we want this to be exposed to the outer world. So we need to make sure that you select the accepting traffic from anywhere as the option. All right, so let me now go to backend deployment instead. Right, so let me go to backend, and then in the backend, let us now configure the CI/CD pipeline. So I was mentioning about CI/CD pipeline a lot of times. So let us actually see how to actually set that up. So instead of writing the workflow file ourselves, we are going to ask Azure to write that for us, and that's going to make things a lot easier. So I'm going to go on the deployment options. Let me quickly find that where that is. Right. All right. So if you go and if you on the overview tab, if you scroll down, then there is a get started options, and under there is a setup deployment. Right. So we are going to click on set up the deployment options. And here you can see that you can also find it under settings and then deployments, that will take you to the same page. So first you need to sign into your GitHub account, which I already have done. If you have not, then there will be a button then that will take you to your GitHub authentication. You just need to provide it the permissions and it will be able to access the repositories in your GitHub account. So I will select the organizations, which is going to be this one, and then select the repository where your application code is located. And then this is going to be the repo. So this is the same repo. Yeah, so this is this repo right here. Yeah, this is the repo that I will be using, and I'll be using the DSW Azure branch. Let us actually do one thing. Let us actually delete all the things that we have here. Just a second. I'm going to do that from the terminal because I don't want you all to be confused with the workflow that is already over there. So git pull, I'm going to just delete the workflow files that are over there. All right. So, and I'm going to delete the entire folder over here. Not the entire folder because you might want the static and Azure Web App workflow. This is not for the part of Docker. Please don't be confused with this one. This is for the standalone Azure system. So I'm going to just delete the one which was related to Docker. So I'm going to delete that one, right? And I'm going to do, so imagine that there was no file over here. So I'm going to do git add, and then I'll just commit this change. And then let me actually push this code. All right. Okay, so this file was deleted now, and then it should be reflected in my code as well. All right, and if I go to GSW Azure branch, and now, yeah, so now there are only two workflow files which are not related to this this part of the system. So we don't have any files that is conflicting to our project, so that is totally fine. So let me go back to Azure, and then I will select the branch as DSW Azure, and then with the repository source, since I previously mentioned we are going to use the container registry, and since we already created one, right? So we created one for the backend and front end, so we are going to use that. So since this is for the backend, we are going to click the backend registry, and now it has the set option to select the image which we already built, right? But again, if you once you trigger this, once you set up the GitHub Actions, it will rebuild the image, and that newly built image will be pushed rather than the image. So remember, there is already one image in our registry, right, for our backend. So that will also be there. But since we set up a GitHub Actions CI/CD pipeline, it will build a new image from the GitHub. So whatever code that there is in your GitHub, so it will build the image according to that rather than the one that is already there in your container registry. So you don't even need to push the image to the container registry like we did yesterday. It will create every time when there is a change in the repo, it will create on its own, and then it will push that. So it's going to be fine. And for the image tag, the image will be tagged according to the commit ID that we have. So I will show you what this means in a second. So every time there is a change in your application code and you push it, there will be a commit ID, right? So I guess most of you already know that every change in your Git is tracked with the help of commit IDs and the commit messages, right? So that is what Azure will use to deploy the new images. So your image name will be tagged by the commit ID has. Yeah. So that's going to be, and for the Docker file, if you just quickly go here, let me actually put this on a different tab so it will be easier to switch. Yeah. So if you go over here, you can see that the Docker file for the server is inside the app/server folder, right? And here is the Docker file. So we need to provide that path. So I'm going to put the path that it was dot slash, and it's going to be the server and slash. So this is going to be the path of your Docker file. So you need to make sure that the path is set correctly. Otherwise, it will not be able to find the Docker file in the root folder, right? Because we have two different folder for our client and server, and it has two different Docker files, right? So we need to provide the full path to both the client and the server. And for Azure Access, just set it up as the user assigned identity because that's the latest one. So this will provide all the necessary credential for Azure to connect to GitHub Action and for GitHub Action to connect to Azure. So it gonna happen both way. So GitHub Actions will get access to uh, push the newly built image. So it will build the image in its own GitHub Action runner or in its own server, right? So that image will still be in the GitHub Action server. So it will need some permission to push it to the container registry in Azure, right? So for that, it's going to use the user as an identity, which we can select from here. And we can now click on start continuous deployment. So it has already started and it will create a new file in your GitHub. So let's go ahead and actually check that out. So if I just quickly refresh now, you can see, just a second, it's not over there right just yet, but it will be created in just a second. Let us just wait. I hope I selected the right branch, right? Yeah. So I guess the workflow should be created now. Let us go ahead and see this GSW Azure. Yeah. So you can see that now we have one additional file, right? So this was the file that was created by Azure just now. So let me quickly pull this up in my local, and then I will explain you what that does. Okay, I'm gonna pull the changes, and you can see that there was previously two, but now I have one more file, right? So this was the file which was just added by Azure, right? So this is a workflow file. It's a long file, so I'm just quickly going to rename this. So this is going to be Azure container app. So that's going to be for the backend pipeline. Yeah, so I'm going to rename that accordingly. So this is for the container app, and then we are using, I renamed that for the ease of workflow. I'm going to copy the same name, just a second, Control C, and then I'm going to just replace this over here as well. All right, so let me quickly save that, and now I will explain you what is there in the code. All right, so this is basically a simple GitHub workflow file, which we already covered in the Azure session. So if you have not watched, I would recommend you to watch, but even then I'm going to walk you through over this. So it's a YAML based file. It's a key value pair file. And first we define the name of this workflow with the name key. And then this will define on what action or on what event, what are the steps. So I said basically that workflow is a collection of steps or the command that will run, right? So whenever there is change or whenever there is some event. So all the commands will be under the job section, right? So there will be different steps and then actions that will be performed, but on what case, when should I execute this event, right? So for that, GitHub is going to look for the on tab, and here you can see that it will run whenever there is change or push change, whenever you push something to the GSW Azure branch, right? So if you have some additional branch, then you can just put them under comma and then add the other branch as well. So you could do it that way, and it will run every time there is a change in the source code, right? So it will look for changes in the entire repository, and also if there is a change in this particular workflow file, right, .yaml, right? So yeah, so it will look for the changes, but since this is for backend only, since this pipeline is for backend, we don't need to run this every time when there is a change. So let's say I changed a JS file in client, then I don't need to run the backend pipeline, right? Because the backend is completely independent of the front end. So I can change the path, and I can just say /app/server. Yeah, so that if I do it this way, like start, so it will only run whenever there is a change in the server files. and any files inside the server folder, it will only run that, and that is actually what we want. And also this workflow dispatch is telling us telling GitHub that you could also run this workflow if I click a button in GitHub Actions tab as well. So even in the hub, there will be Actions tab, and I could run the workflow from here as well, right? So you can see that the workflow was executed recently as well. I will show you that as well, but you could run the workflow from here if you enable the workflow dispatching. And for the jobs, so basically we have a series of jobs that we do over here. So it had just one in this case, build and deploy. It has combined both the steps in one, but we do have a lot of things going on here. So first we set up a Linux environment using Ubuntu where all the steps will run. And then we have, first we check out to the branch. So checkout is nothing but giving GitHub Actions the permission to see the code in a repository. So it will get access to all the code within a repository, which is required, right? Because we need to build Docker file, and then we need to see the Docker file and build the image. So for that, it will need access to all the code that we have. So it will check out the repo. And then we are now logging into Azure, because remember, we need to also push the code to the Azure Container Registry, right? So it will need the permission from permission to push the Azure. So that is why we are using the Azure login command, and we need to provide it with client ID and tenant ID, and all of this is set up with the help of GitHub Secrets automatically for you. And you can check the GitHub Secrets from the settings tab. So if you go to settings in your repo, and then if you go to actions, not actions, sorry, secrets, and then actions, so you can see that there are a lot of secrets which was added by Azure. I do have a lot of other secrets which I use for the purpose as well, but you can see, let's say in this example, GSW-mon backend Azure client ID, right? So if I search for that, yeah, GSW-mon backend Azure client ID, you can see that the value was already set, right? So you cannot see the value over here. You can change that and update that, but it was set up automatically by Azure for us, because we provided Azure with the necessary permission to write to our repos. That is why it created this secret itself, and it added that under the client ID, because we don't want these secrets to be exposed, right? Because if we just put it directly in our YAML file, anyone with access to our repo can see the actual value, right? So we don't want our things like API keys or these Azure secrets to be exposed. So that is why we use GitHub Secrets, and then we put the value over there, and then we reference that using the secrets keyword. And you need to use the $sign and the double curly braces to access those secret variables. And once we are logged into Azure, and now we can actually build and push the container image tree. So it is using a pre-built action. So this will use a pre-built action, which actually we need to provide it with different things. Like we need to provide it with the location of the server directory, which is set up correctly in this case. So it's going to be /app/server. And we need to also provide it the registry URL. So since we selected this during the setup, it is set up as correctly. Because if you remember, we set up the registry yesterday. If I quickly show you that registry, right? Container registry. If I can show you the container registry, just a second. Let me just, in the meantime, like if you have any questions, then I will be more than happy to take those as well. Not, I don't want to create, I want to just see them. You can see that for the backend, the URI was this one, right? Login server URI, gswmon backend.azurec.io. And it's exactly the one that we have over here, gswmon backend.azurec.io. And it automatically, Azure automatically inserted the username and password because we don't want it to be exposed in the YAML. And then we provide it with the container app name. You can see that the container app name was Azure Mon backend, right? For the backend application, we provided with the resource group, and then it will use the image based on the SSID, because I told that your image will be tagged according to the GitHub commit ID, right? And the GitHub commit ID is available with the help of this variable. So if you, in GitHub Action, if you use $curly braces and then github.ssa, it will take the commit, the last commit ID, which triggered this event. And then you can provide the build arguments over here. But for our backend, we don't have any build arguments because it's a express-based application. So we install our dependencies and then we run the application. Instead of building it, we run the node packages, the node application, right? So instead of build arguments, for our client, we'll need that, because remember, we need to provide the white API URI or the API link in our front end. For that, we will use build arguments, because we need to build it, because front end are always built, right? They are not run. They are just solved using some server. It's not a runtime environment, right? But for backend, we need to put the actual runtime environment, and for that we are going to put it the environment variable, and that's going to be you can check the GitHub repo I provided. And if you go to code, right, not in code, let's actually show it from here. If you go to part 3, just let me refresh this one quickly. Refresh this quickly. And if you go to part 3, then I have provided the instruction that you need to change, right? So in for backend, I asked you to put this additional variable, right? So you need to put environment variable, and you need to provide the Atlas URI vary using secret. So let us just copy this section, and then let me just put this over here. Yeah, so you can see that I provided the environment variable. By the way, you need to have one tab over here. Okay, so that is now properly formatted, but you need to add this secret as well, right? Otherwise it will not be able to read, because we are just providing it the variable, but we are not actually set. If we did not set this up in the GitHub repo itself, then GitHub will not be able to access. So let's go ahead and set this actually. So the variable is going to be named as Atlas URI, which we already have done in first part. So I might already have that, but I am still going to show you how you can actually do that. So go to settings, and like I already said previously, go to secrets, and then under actions, you need to add a new repository secret. So create a new repository secret. The value should be Atlas URI, and the value of the value should be your MongoDB Atlas URI, right? So if I go to my code and under .env, I can not under .env for my server, under config.env, I use the URI right over here, right? So whenever you create a Atlas database, you will get this URI, and also you need to insert the username and password properly over here. And since we do not commit any config.env or any credentials to our GitHub repo, because we don't want anyone else to see our MongoDB access URI, otherwise they will be able to access our MongoDB database or anything like that. So we don't have this in our GitHub, because we put this in the gitignore file as well. So if you go to gitignore, you can see that I have commented out everything that contained these secret things. And also we put it in Docker ignore. We don't even want this to be in the Docker image, because anyone can reverse engineer the Docker image and also see the entire application code of the base. And so they will be able to access if we expose it as well. So we need to put this in both Docker ignore and Docker the git ignore. All right, so what we did, what we are going to do now is that, let me go back, and you need to put this over here. So just not this, you need to put the actual value. So let us go ahead and copy this one, and then you need to put the secret URI. You can get this from MongoDB Atlas, and you can add a secret, but I have already done that. And so if I go to actions, then I have already added that previously, so I don't need to re-add that, but I could have done that as well. So it will update that if there is already one, and you can even go here and update the variable value. So that is already done. So once that is done, let me come back here again. So once that is done, everything else is almost set. We don't need to worry much now, because we just added the environment variable, and that should fix everything. And we also made sure that the workflow only runs whenever there is change inside the server folder or the workflow file path, right? This specific workflow file. So I'll click on Control S, and I'm going to actually push this. Let's time use the GUI interface. So update workflow, right? I'm going to commit this, and I'll just push this. All right, so yeah, I guess that is done, right? So let me quickly see this. If I go to code, and then if I go to GSW Azure branch, let me see if my changes are here. Under workflows, you can see that it is here, right? So this was not that one, this one, the Azure Container App backend. So it is just pushed right now, and you can see that there is a orange icon that is over dot icon, right? So that means that our action has already started, and you can see that using the actions tab. So if you go to action tab, you can see that our workflow has already started, right? So if you click on this, you will be able to see all the details as described in our workflow file. So you can see that the checkout process is completed. It has also, you can see the logs of all the steps as well. So it is now actually trying to build and push the image to the container registry, right? So it will execute all the steps that was there. So it has currently checked out to the repo, and now it has also logged in successfully, and now it is executing these steps, right? So you can see all the things step by step, right? So first and second step is done, right? First and second step, and then now it is executing this step. So this means that our image is being created, and then it will be pushed, right? So we can watch the logs over here, and once we see this, we should be able to see two different things. So we should be able to have our application running, And also we should be able to see a new image change in the container registry. So there will be a new image which will be pushed over here, right? So that should also be reflected here. All right, so you can see that we have a new image registry, right? So, and let me see, I guess this is not the one. I guess that action is still running, so we need to wait for a few more time, and then we will check with the app as well. All right, so let us wait for this workflow to complete. So it's yeah, doing its thing and trying to push. And this is the beauty of CI/CD, because we just wait for it to complete, and then we will see our live application. So first we will deploy our backend, and because we need to also provide the URL for our backend when we build the application for our front end, right? So we need to provide this as a build argument. So that's why we need to first deploy the backend. And seems like it has completed. There is a green check. So that means that everything is done. So let me go to registry. Yeah, GSW1 registry, and repositories now have three different images, and I guess it was GSW1. And you can see that the one which is right now was 2:44 p.m. because it's 2:45 p.m. right now, and this is the latest image. And if you see that, if you see, this is the tag, right? So this was the image tag. This is the full image tag 1DB4A, right? And this is actually the GitHub commit ID for the last commit that we did. And you can verify by that by going to GitHub. And let me quickly pull this up. So if I go to code, right, and then if I go to the GSW Azure branch, you can see that the last tag was 1D4A3D, right? So this is going to be exactly the same commit. So this commit actually matches the one that we have over here. You can see that it's 1DB4A. So that is how every time you make a change, it will use the commit ID as your image tag. So that is also already done. So let us actually see if our application is now running, because earlier we used the quick start image, right? But now it should actually use the new revision. So if you click on application and under revision, you can see that there is a new revision now, right? It was created just a minute ago under 2:44, and it's in the activating state. So you can click on view details, and now you can see that a lot of status, and you can see the different logs like system log. You can also see the under logs stream, you can see the actual different logs of your applications. You can also access the console, right, of your container. You can see other logs as well and different metrics and all those things. But the most important thing that you need to see, if I go back here again, I click on view details, you can see that there is a message, and that message says that the target port 80 does not match the listening port 5050. And that is what I said earlier, because we need to make sure that we set up the target port correctly, because our backend, the earlier used quick start image was running on port 80 itself, right? So that's why we were able to access it. But our container is running on port 5050, so we need to change that. So that is why we go to ingress under settings, right? So under ingress, here we need to make sure that the target port is set to 5050, because remember, the container is running on port 80. So that is why we need to make sure that the target port is also updated, right? So, and that is in this way the ingress will be able to forward the request to the corresponding port. So if I click on save and update, now the ingress is being updated, right? So let us wait for this to complete. Just again, like in the meantime, if you have any questions, just let me know. By the way, I would also like to know how many of you already used Docker before, and if you ever deployed the Dockerized applications by using Azure or any other service provider. Have you done that before by any chance? Please let me know. I would love to know like what sort of services you used and if you faced any challenges. So things like my port is now updated. So if I click on endpoints, which I have in the ingress, so this is how I will be able to access the backend of my application, right? So I can click on under ingress, you will be able to find the endpoint, and this is actually the URL where my backend will be running. And if I can zoom that up for you, you can see that I am able to access my backend, right? And I can go to /record, and you can see that I have also retrieved all the employee records, right? So this is actually fetched from the MongoDB database, which is running right now. I do also have a MongoDB setup. Please watch the first part of the Azure session one, so you'll be able to see that, but I can show you that quickly. So it's actually getting these records from MongoDB. It's making an API request to MongoDB, and that is how it's able to access the thing. So this means quickly sign in. I'm going to pull this up on a different screen. Just a second. Give me a moment. All right, so now that I have logged into my MongoDB console, I can show that to you. And you can see that I do have a database which is already running, right? So this is actually the database, and I can show you how you could have got. So this is the URI that we used earlier, right? So we replaced this with the actual password that I used when I created this database, and then we pasted that in the config.env file. And I can also browse the data over here. So under browse collections, if I do that, then I will be able to see the records as well. So we have a collection for employees, and under records, like we have three different records, right, for three different employees. So that these are the dummy employees. So this is how our application is actually getting the data. So that means that our backend is running. So now we are all good to go ahead and do the same thing for our front end. But remember, we need to provide the API URL. So this, we need to provide this specific URL without the record one /record. So we need to provide this entire URI when we build the client, because client will need to make requests to the backend. So we need to provide this during not the runtime, but the build time itself. So we will also keep that in mind when we deploy our front end. All right, so let me go back to front end now, because backend is running fine. And now I'll set up the deployment here as well. So under settings and then deployment, I will select the organization, which is going to be the same one. I will also do for the repo. So repo, it's going to be the same. And then branch is going to be GSW Azure. And the registry is going to be the GSW Mon frontend or backend. All right. So you can see that it is not able to connect to our front end because it is asking for certain permissions. So we need to enable the authentication permission in our Azure registry as well. So let me actually go ahead and do that. So we for backend I already enabled that. So that is why we did not have any issue with that. But I'll show you exactly how you can enable that as well. So you need to go to your registry, and you need to make sure you go to settings and then access keys. So go over there and just click on admin user. So this will enable an admin user which has the necessary permission to actually fetch the images from the container registry. So it will show you the username and password that you can use to authenticate. So our container app will use this credentials. So let me go there, and now if I click front end again, so yeah, I don't see that error anymore, right? Because now it is able to authenticate using that username and password. And since both of them are in the Azure in same account, so I don't need to even set up the username and password manually, because it will automatically fetch that. And now I need to provide the Docker file for our client. And if you remember, that was inside /app/client, right? So this is going to be the Docker file path, and then everything else is going to be same. All right, so it has started the continuous deployment. So again, this will also add one file in our repo, and that's for the front end. So let us go ahead and actually see that. Let's wait for this to complete. And yeah, so let's see if there was a change. If I go to code, and then for the GSW Azure branch, and then under .github workflows, yeah, there should be a new file added over here. It will be added. Hi there, hello, nice to be here as well. We are almost towards the end of the session, but still, even if you did not get a time to join earlier, all of my parts are out there in YouTube as well. So even this and the previous two parts are there in YouTube. So please make sure that you rewatch the parts. Also, super important link that I shared earlier. So please bookmark the session resources session, the document, and then I have provided all the instruction and the command in this Notion page. So you will be able to follow by watching my recording and then following the instruction in the resources page. So yeah, so right now we are deploying the front end for our application using the container app service. So let us see if there is a new file in our workflow. And yeah, you can see that there was one file which is added by Azure, right? So we also need to make some changes to this file. So let me pull this in our VS Code. All right, so I'm going to do git pull again. Git pull, right? So I should be able to get that file. Yeah, so now I think I have that file. So this was the file which was added by Azure just now. So let me also rename this file because it's a very long file. I don't want my name to be like that. So I'll rename it as Azure Container App, and then this is going to be front end pipeline, PIPE. All right, so that's That's going to be the name of my file. And let me also copy the um, name and then rename them over here as well. All right, so let me quickly change that. All right, so let us now see how the workflow looks. By now, you already know what all of this means, right? Because I explained this, and if you want to have more clarity on GitHub Action, please watch my Azure session. I have covered this over there as well. And also for path, I just want, since this is a pipeline for our client application, and all the client code is inside the slash app slash the client directory, right? So we don't need to run this every time when there is a change in the entire repo, right? So if, let's say, if I just change the compose.yaml file or the and .env file, not the .env.ignore file. So this pipeline will run, but we don't want that. Even if I change the backend file, this pipeline will run. But since the client end is completely independent of front end, I don't want that. So I'm just going to provide it the path, right? So this is the actual path that we need to put. So every time there is a change in any files and folders within the client folder directory, only then this pipeline will run. So that is one change that we added over here. And then everything else is same, right? It will start a GitHub Actions runner. It will check out the code which is there in the current repository. So it will get access to all the code that we have. It will authenticate with Azure. And then once again, these secrets are automatically added by Azure in our repository, because we provided Azure with all the necessary permission to write to our repository. So it added this for us. So we did not have to do this manually. And then again, it is using the same action. We need to provide it with the Docker file, the app source path, right? So the app is inside the slash app slash client folder. So this needs to be the path of the Docker file, which is correct in this case. Our Docker file is indeed within the slash app slash client directory. So that is correct. The registry URL, this is going to be the front end registry URL. Remember the registry URL that we used, right? So this was for the backend, and for front end, it was gswmon frontend.azure.io, right? So this is masking with this one. Again, the registry username and password, which we enabled using the access keys, right? So we went to access keys and we enabled the admin access. Azure automatically added that for us as well. So it's utilizing the GitHub secrets again, and it added that for us. And then the name of the container app where we want to deploy. So for our container app, if I show you over here, not that one, not the URLs. The container app is named as GSWMon frontend, right? So again, the name has to be matched, the resource group and the image. And here also you see that the image is tagged according to the commit ID, right? So that's going to be that. And now for the front end, we need to use the build arguments, because I have told it a couple of times before as well. For backend, we just need the MongoDB URI for the runtime. We don't need it using build time, because for our Express application, we don't build it, we just run it. But our client application, since it's React, we need to build it, and there will be a dist folder which will just contain the HTML, CSS, and the JavaScript file, which are the static file, and we serve that using Nginx, right? So all of that will be in the container. So the container that will be running in our front end, that is actually the Nginx container and not the React container. So we need to build the image, and for that we need to provide the URI first end. So let us go ahead and actually change that. And I provided the instructions in my Notion page. So this is the thing that we need to add. So we need to provide this byte API URI. All right, and again, I'm using the secrets to insert the value. And so this means that you need to add this secret in your GitHub repo. So let us go ahead and actually do that. So I will go ahead and go to settings, right? So, and I will delete any, to show you all the steps, I will delete any byte API URI link that is there right now. So yeah, so I'll delete this byte API container URI, right? So that was the one that is using byte API container app URI. That's the one that we are using. So I'll delete this, not edit. I'm going to delete this entirely to show you the entire process. Let me use my password. All right. Yeah. And then now I'm going to go ahead and click on new repository, right? So this is going to be the name. So it's byte actually, not height. So whatever you use after the secrets dot, so that's the variable name that you have to put, right? And then this is going to be the URI of the backend. So this was actually the URI, right? So we set it up earlier. So hi Shraddha, so we are almost towards the end, but glad that you joined. So we're just quickly wrapping up the session. So we are now we deployed our backend application in Microsoft Azure Container App, which was already built, and then we pushed it to the container registry. But we automated all of that process with the help of CI/CD pipeline, and now we are doing the same thing for our front end. So you can see that our backend is up and running, right? And it was able to fetch the record as well from the MongoDB, and this was the records that was there in MongoDB. So the URL without the slash record, so you have to copy this entirely. You can also, by the way, get this from the container apps section. So from container apps, if you go to GSW on backend, and if you go to ingress settings and then ingress, right? So here you will be able to get the path as well. So you can just copy this value, and then you need to add this inside here, the secret settings, and then I will just add that. Please don't add any slash after the URL, because the application is programmed in a way that it will add the slash automatically, so you don't need to add any slash after the .io path. All right, so I'm going to add this secret. So now that our secret is added, the GitHub action will be able to access that value during the build time, and that will be built inside our React application, and now that will be ready to go and serve. So let us go ahead and actually push changes as well. So update client workflow, right? So I'm going to commit these changes. All right, and then yeah, that should be done in just a second. And now let us see if that changes is reflected over here, and let us see if the front end action is still running. Yeah, you can see that the workflow file was indeed uploaded, right? So we have the front end workflow file, and you can see there is a orange dot. That means that our action is already running. So let us go to the action tab, and you can see that the client workflow is also running properly now. So you can click on that to get the details. So right now, these are the pre-steps that GitHub Actions will do. It will try to do some pre-checks in order to log into Azure, and then it will do all the steps which are mentioned in the workflow file. So it will execute these steps one by one. So first we'll check out to the branch, and then log in, and then finally build and push the image to the front end container app service. So you can see that the Azure login is also succeeded. So now it will actually build the front end image and then push this image to the container registry. You can check all the logs from here. And once we have that, so if we go to the container registry for front end, we should be able to see a new image over here. And if you also go to the container apps front end, then you will also be able to see a new image revision, and we should be able to access our application. Right now, we don't have one, but soon, once the workflow is done, we will be able to see that. So let us just wait for some time for this to complete, and we will be able to access our application. Yeah. So yeah, we are almost running towards the end. So in the meantime, if you have any other questions about containers and everything that we did in this amazing 3-part series, then just let me know. All right, so right now you can see that it is running the instruction in our Docker file, right? So yeah, just the log output for that, and it will try to just push that. Let us wait for this to complete. It might take some time depending on how big your Docker image is. So yeah, we just have to wait. Enjoy music until the skill process is complete. All right, so looks like our build process is also completed now. So we can go ahead and check that and verify all of that. So let me first go to container registry, and for front end, let me go to the repositories, and I should be able to see the new image. Yeah, you can see that this was the image that was pushed recently, because now it's 304 and it's 302, and I can also verify that using the tag. It is using the commit ID, if you remember properly, so 7B05. And if I go to my GitHub repo and then code, right? I can just check the commit ID. I can go to GSW Azure, and you can see that it was 7G05, right? So it is indeed the image which is for the latest code that we have just pushed into GitHub. So the image is properly upload it to container registry. I just showed you that the image is properly pushed into the GitHub container registry, right? So you can get the different configuration. You don't need to understand all of this. You can just check the tag to see if it is the one that you pushed recently. So that means that is properly set. So let us go ahead and see if our front end is also properly set up, right? So the container app, which actually runs the container, right? So we can click on application and then release and replica. Okay, so still not running for some reason. Yeah, you can see that it is running now, and you see a green tick, and you can click on view details to see that it's running properly. So you can click on system logs to check the logs for the application. So this is the log that you will see, right? So everything is seems to be running fine. So let us go ahead and actually check that. So if I overview, and then I can click on application URL, and here you can see that it is the application is running fine, but for some reason it's not able to access the backend, because otherwise I would have seen you could have got the record. You should be able to see the record. So let us try to debug this, right? Because things happen in developer life, and we often encounter errors, right? So let me quickly send the request again in the inspect tab, and I can see that it is failing the record because, all right, so we do have some, I guess, mismatch with the URI path for our backend. So it's undefined, it's set to undefined for some reason for build arguments, and that is why it was getting this error. All right, so we do have the undefined value over here. Otherwise, the backend URI seems to be fine, right? So let us quickly just copy the backend URI and check if it's the same thing. Yeah, not that one. All right. Oh, so, it's sending the request to the front end itself. So for some reason the API URI was not set. Okay, so let us go ahead and try to check this. Okay, let me go ahead and check the container detail, and then the environment. This is not a runtime environment, so we won't be able to see this over here. So let us go ahead and actually check the logs that was used. I believe like there is some issue with the naming that we have done over here. So that's going to be the build arguments key, which I believe is true. Yeah. Okay. Yeah. So I found the error. So it should actually be build arguments rather than build arguments key. Thanks. Yeah. Hey Ritvi, welcome everyone. Although it's we are towards the end, yeah, please go through the recordings. I also follow the Notion page that I have provided, and it will also help you to follow along the session that we have. The link to the Notion I have just pinned it on the screen. So the mistake that we did over here is that this should actually be build arguments rather than build arguments key, right? So I also showed you some of the steps that you should actually use to debug. So remember what I did to debug this. So I just went to the front end, right? And then I inspected this, and then I opened up the network tab, right? So I just enter the site again. So I can see that this was the API route, right? But the API route seems to be the same route. So this is actually the same route which is over here. It's not the backend route. So that means that it's sending the request to itself. So that is why we are getting the error, because it need to actually send the request to the backend. So I figured out that there was some error when setting up the API URI, and I checked my pipeline. So I saw that the part where I set up the API URI, it was actually like this, right? Instead of build arguments. So that was the error. So this should have been build arguments instead of build arguments key, which I've also mentioned in the Notion. So make sure you change that. So I will go ahead and commit this, right? So let me use terminal for this one, git commit, and that's going to be update workflow, right? And then I am going to, sorry, I did not add the changes, so I need to add that first, and then I'm going to post the changes. All right, so now the action should rerun, right? So sorry for the trouble, and that is how you fix things as well. So let's go ahead and see this. So there should be a new action because we just pushed the change. So we need to wait for some more time for this action to complete. So there will be a new revision deployment, and then our application, the front end should work totally fine, right? So let me close everything now. I just want to have my front end and my back end. Everything else should be same. Okay, there is a good question. If I use your code by following along for learning, it is equal to copying. See, for learning or just for to get an initial understanding, you could totally just clone my code and then follow the instruction that I gave in my Notion page, and then just try to replicate it. But that will not be super helpful for a long run. And for that, I would highly recommend you to use your own application project. So if you have built any application previously, it could be in any stack, then try to implement the concept that you have used rather than just copying code line by line and then using it for once or twice just to grab the concept. It's totally fine. But for you to be a good programmer or a good DevOps engineer, you need to grasp the concept rather than the hard code, and then implement that concept in your own application. So that is what will make you a good programmer. So you can take other source code which are publicly open source projects and all those things, or your own application, and just try to implement these things yourself, and that is how you will learn. So it's totally fine to follow along, but also try to do it yourself in different kind of projects, and that will help you become a better programmer as well as a DevOps engineer. All right, so let us go back and see if the workflow is still running and completed. All right, so it's still running, so we need to wait for some more time. We need to wait for this to complete, and then after that we will check if there is a new revision. Remember that we have like 2 revisions previously, but there should be a new one once this is completed. All right, in the meantime, if any more questions, then I would be super delighted to help you out. Yeah, it's installing the packages again, so we need to wait for this to complete. Let me just play some background music for some time while this gets completed. I guess now it has completed. Mhm. All right. Let us see this. Yeah, and also to add one point to the previous Ritvik question. So it's good for learning to use other code and then but the most important thing is to actually do it yourself and try to build your own projects. And specifically, if you are participating in a hackathon or any specific MLS hackathons, then that is not allowed. So you can use it to learn on your own, but you cannot or you should never submit others' code in any competitions or hackathons. So that is one thing. Just wanted to point that out. Yeah. Okay. So this is completed. So let us actually go ahead and check this out. So if I go there to my revisions, and if I click on refresh now, so there should be a new revision, right? So you can see that there was a new revision created in just a few minutes ago. So if I click on detail, and now you can see that if I click on system logs, the application is working fine. So let us go ahead and actually check if the application is running now. So if I click on application URI, still I don't see. Okay, so still we have some error. So we need to do some more debugging over here. And I don't know what is causing this error, because now, okay. So yeah, no. It was just some delay in the response because everything is fine, right? Because I just inspected this, and if I went to network tab, it was making right request, right? Because if you go to record, now we have the proper backend URI, and it is pointing to the right API path as well. And you can see that the status code is 200, so that means that it got the record. It was just delayed response. So yeah, it is working totally fine. I can create a new employee, right? So test user, right? So and make them a DevOps engineer, right? So you can save the employee record and do this thing. So it's just for demonstration purpose. Yeah. So that is done. So we have folks finally completed the entire Docker series, right from the point where we learned what Docker is, to learning different commands, to writing Docker files, Docker Compose. We also learned about volumes and networking, and we also learned how to push this image to the container registry. And finally, today we learned about how we can actually deploy this. So we have reached to the end of the workshop, and the series. So thank you everyone for being here. We do have one question before I hop off. Do we also have to upload challenges to the post? Uh, there are existing GSW challenges which you can check if you go to gsw.mls.io. So you will be able to find the challenges over there, but those challenges are not related with this stream. So you can do it on your own, and you will also find the dev post link. I guess it is also the link is also there in the Discord server and FAQ. If you go over there, you will be able to find the challenges dev post link where you can actually submit the challenges. But that is totally different from what I have done in this stream. So for my stream, there is no any other challenges. This is just for you to learn. You can do this on your own at your own pace. If you can watch the recording, you can also follow the Notion page that I have given. But yeah, you can also submit. You can check out all the challenges in the FAQ. I highly recommend you to ask any general question for the GSW in the GSW Cloud Week channel and not yeah. Okay, cool. Bye bye everyone. Thank you and have a great time ahead. I hope you learned something, and I hope that you will take these lessons and implement them in your own projects. Bye bye and have a great time. Bye bye. I will see you all. Have a great time ahead.